Assalamualaikum and hi everyone. Our topic today is Gauss quadrature. The term quadrature here meaning by determining the area. So we can say that the underground principle of the Gauss quadrature is similar with the trapezoidal rule and Simpson's rule. Both of these methods used to approximate complex and complicated functions. The idea of Gauss quadrature is we replace our function with the respective equation and the selection of equation depending on the type of Gauss quadrature that we want to use. Before that, you need to know that Gauss quadrature have several kind of rule, but in this class we only focus on two types, which are 2-point Gauss quadrature and 3-point Gauss quadrature. These are the formula for the 2-point Gauss quadrature, and the other formula to be used for the 3-point Gauss quadrature is like this. Not to worry, you don't need to memorize all this formula, but the most important thing, you must understand how to use both of them. Now let's see how the Gauss quadrature works. Consider the integral like this, function between a and b, function ft dt. For the first step, we need to substitute the value of t with this formula. Then the value of dt into this formula. And at the same time, the limit of integrals, this one, changes from -1 to 1. After the substitutions, we can see the formula change into this form. Then after simplify and factorize the formula, it becomes more simpler to use. This formula transform into this one. If you still remember that we have two types of Gauss quadrature to consider here. Firstly is 2-point Gauss quadrature or 2-point rules, and the other one is 3-point rules. And you know that each approach or each rules have their own formula for their gx function. So let's substitute the value of gx into the approximation formula for the respective rules. Now we substitute this one according to the respective formula for each rule. For the 2-point Gauss quadrature, we substitute with this formula. So it will become for the 2-point Gauss quadrature, and for the 3-point Gauss quadrature, we substitute this one into this formula. So the approximation become like this. So this is the two formula that can be used to do the approximation using the Gauss quadrature method. Let's see the example of the application of this method to do the approximation. One is find the value of integral between 1 to 3 x squared over 1 plus x power 4 dx by using first 2-point Gauss quadrature method, second 3-point Gauss quadrature method, and the third using the analytical method. Okay, so we go to the question one by one. Let's start with the first one. When we look into this one, it's a bit different with the explanation that I given before. Let's look at our notes. What are the differences between our questions and our previous notes? You can look at this one and here. Okay, in the questions, it's using function of x. But in our notes previously, we're using function of t. So the process is actually similar, but instead of dt here, we can change t into x and x become t. Okay, now let's proceed to the first step. Step 1 is substitution. For the substitution, we will use this equation and this equation. X equals to b minus a t plus b plus a over 2. So now our b is here and our a is here. Then substitute the value of a and b. 3 minus 1 t plus 3 plus 1 over 2. So we got 2t plus 4 over 2. And our x equals to t plus 2. For the second formula, dx equals b minus a over 2 dt. 3 minus 1 over 2 dt. Then we get dx equals to dt. The second step is replace. Our integral is 1 x power of 2 1 plus x power of 4 dx. Then we substitute the value of x into here and the value of dx with dt. When the substitution happens, our integral intervals change to -1 to 1. Then we substitute the value of x with t plus 2 power of 2 over 1 plus x change to t plus 2 power of 4, and dx become dt. And this value is actually our gt. Okay, so now it's become like this. If you can recall my previous explanation, we have different formula for different type of Gauss quadrature method. Then we go to the step 3. Find gt value. So for the question A, we need to use the 2-point Gauss quadrature method. So we're using the formula for 2-point methods. This is the formula for the 2-point quadrature method. Okay, now how to get the value for this one and this. Okay, let's see the equation here. Insert the calculation into your calculator. Because we didn't have alphabet T in the calculator, I will use alphabet Y as a replacement. Then click calculate and insert the value of T, this one, minus 1 over square root 3 equals, so we got 0.3971 plus, then again calculate, insert T equals to 1 over square root 3, and we got 0.1472, and total up becomes 0.5443. And move to the step 4. When you look at here, this is the formula that I've mentioned in the previous explanations. So in this case, our function is ft dt, so it becomes gx dx. For this question, our given function is fx. We can just simply change the ft dt to fx dx. And gx dx into gt dt. Get back to our original function. If integral between 1 and 3 fx dx equals to b minus a over 2 integral 1 minus 1 gt dt. Then our integral is x2 over 1 plus x4 equals to, our b is here, b a 3 minus 1 over 2, and value for this one is from here, 0.5443. So our final answer is 0.5443. This is the approximation using the 2-point Gauss quadrature method. And now our second question is using 3-point Gauss quadrature methods. Okay, we can just proceed the same step until the third step. Okay, at the third step, we will use the formula for the 3-point method. The formula is longer than the 2-point methods. Then insert the same equation that we use in 2-point Gauss quadrature method and replace the value of t with this one, 0, and this one. So it becomes 5 over 9, calculate minus square root 3 over 5, 0.4613 plus 8 over 9, calculate t equals to 0, equals 4 over 17 plus 5 over 9. Again, calculate square root 3 over 5, 0.1277. And we solve it, we get 0.5364. Then proceed to the next step, step 4. For the 3-point Gauss quadrature, we use the same formula with the 2-point, but we just only change the value of gt based on the value that we get here. So now our function is 3, 1, just same equation, same function, same formula, 3 minus 1 over 2, but now our gt value is 0.5364. And our final answer is 0.5364 as well. So we already solved questions A and question B. How about the question C? Now the question C is about analytical method. Analytical method is actually the exact value for the integration. So to solve the analytical method, just insert the integral function into your calculator. Let's do that together. Firstly, you click the integral function here, okay? Then insert the equation inside the function. X squared 1 plus x power of 4, and click next to the interval column. So you click 1, then 3, then just click equals. So this is the exact value that you got for the question number C, 0.5345. And now it's done.